Hello students, in this video we are going to talk about logarithmic functions and expressions. To better understand what is meant by logarithm, consider that you have an exponential function, which one I'm taking an example, y equal 2 to the power of x, and its inverse. Since exponential functions are one-to-one, the inverse of y to the 2 to the x power exists, and also is a function. So as you know, to find an inverse of the function, you interchange x and the y values in the ordered pairs of the function. So this means that we are interchanging domain and range. So the inverse of function y to the 2 to the x power can be defined as x equal 2 to the y power. So the graph of these two functions are reflection over each other over the line y equal x, which one you know is called the identity line. In general, the inverse of y equals b to the x power is x equals b to the y power. In x equals b to the y power, y is called logarithm of x. It is usually written as y equal log base b of x. And one more time, it's written like that and it's read y equals log base b of x. You have here the definition of the logs. And I'm going to go on the simple way. Let's, if b is greater than 0 and supposed to be greater than 0 and different from 1, for x greater than 0, there is a number y such that log base b of x equal y if and only if b to the y power gives you x. So in this video I'm going to go and show you some examples how to go from logarithmic to exponential form. Example number 1. On this example, I have log base 8, I said of 1 equals 0. So based on definition of logs, I am going to say that base b to the power of y is going to give me the x. So how can I write that? I can say 8 to the power of 0 gives me 1. And that is true. You know that 8 to the power of 0 is 1. Let's get another example. Log base 2 of 1 over 16 equals negative 4. Again, based on definition of logs, my base in this case is 2 to the power of negative 4 is going to give me 1 over 16. How can I write that? 2 to the power of negative 4, 1 over 16. Since we are dealing with a negative exponent here, I am going to find the inverse of that. So I'm going to say 1 over 2 to the power of 4, the power changed to positive, equal 1 over 16. Which one is completely true? 2 to the 4th power is 1 over 16. So in these two examples, we wrote an exponential function using a logarithmic function. Now, in this example that I'm going to write right now, we have to write each equation in logarithmic form. So it's the opposite what we did so far. So we have 10 to the 3rd power equals 1,000. We know that the base is 10, the y is 3, and the x is 1,000. So I will go in the log form. I say log base 10 of 1,000 equals 3. If I want to go backwards and I check out my work, I can say 10 to the power of 3 is 1,000. Is that true? True. Really true. 10 to the power of 3 is 1,000. So in this case, I went from exponential to logarithmic form. The last example that I want to share you says evaluate logarithmic expression. Find the value. For example, we have log base 2 of 64. How much is that? So you have the base 2, we have the x is 64, and based on the definition, this is equal with y. We are going to use the definition of log. 2 to the y equals x. So I'm going to write down, let me use different color here, let me use black again. So I have 2 to the power of y equals 64. Now, as you can see, this is changed to an exponential function, which I know how to solve them. This exponential, you have to solve by using the same base. You have 2 on the left side, 64 on the right side. So to solve, we have to find the factors of 64, and we have to make it a 3. So divide by 2 is going to give me 32, divide by 2, 16, divide by 2, 8, divide by 2, 4, divide by 2, 2, and 1. So I count the 2's, 1, 2, 3, 4, 5, 6. So 2 to the power of y equals 2 to the power of 6. The bases are the same, so y equals 6. Okay, so that is the lesson. So in this lesson, I explained the key concept of logarithm with base b in general, and I showed you examples how to change logarithmic to exponential form, exponential to logarithmic form, and evaluate logarithmic expressions. Thank you.